Here we go. So let's talk through some of the vocabulary. So what is a relation? It is a pairing of numbers. So an example would be the ordered pairs we dealt with a minute ago on the warm-up. So if you had something like 1, 3 and 2, 5 and so on. Okay, so if you've got a pair of points that you're working with, this would be considered a relation because they have a relationship to each other, right? You have an X that has a relationship to a Y, and that's how we plot them on the grid. Your domain are your X values. Your range are your Y values. And how I've always remembered the difference, and maybe you've heard this before, is that Y values go up and down, so you think of it like a mountain range, like thinking of it up and down. Okay? If that helps, go for it. Independent variable. So typically it's going to be X. Not always, but typically it's going to be X. And it is not impacted by other things. A good example of an independent variable that isn't impacted by anything else is time. Because is time going to change if it's raining, or if it's sunny, or if it's... So time is typically our independent variable. Dependent variables are typically Y, and they are impacted by other things. Okay? So, if I went to go get gas, and it was a different day, right? So you know each day the price changes, right? It jumps up, it jumps down, it stays the same sometimes, but the price of gas would depend on the day, and even the gas station that I went to, right? So that would be something that would be an example of being dependent. So the things that are dependent are things that rely on other things. Now, we're going to talk about 3 ways to express things today. One of the ways is with a graph, like what you did in the warm-up. Okay, so one of the ways is to go ahead and plot your point. So if you had the point 1, 3, remember this is your X and Y axis. This would be over 1 up 3. That would be this point right here. So one of our ways to show our relation is that we can graph, okay, just like the warm-up. Another way that we can show a relation is with a table. So I call them T-charts because it looks like a lowercase t. So this is a T-chart. And I'll just use the same point I used a second ago. My X is my 1, my Y is my 3. So remember, they come in alphabetical order. So the X comes first, the Y comes second. So that's what a table would look like. And typically we have more than one point, so usually we're not working with something this simple. And then the last part, you're going to have a bubble for the domain and a bubble for the range. Dear pass. Okay. Alright, so 1 was my domain because it was my X value. 3 was my range because it was my Y value. And then what we do is we draw a line showing that 1 matches up to 3, that those two are buds. So we draw an arrow showing that those match up to each other. So the table is literally a table, putting in points. The graph is a graph where you're plotting. And then the mapping diagram is looking domain to range. And again, domain are always X's, range are always your Y. So how do you figure out if it's independent or dependent? Basically, you have to answer the question, which depends on the other. So that's what I always ask myself. So how do you identify it? Decide which variable depends on the other. because if it depends on the other one, then it's dependent. If it doesn't depend on anything else, then that's your answer. If it doesn't depend on anything, then it's your independent. So that's how you test. And again, typically time is our independent variable, but not always. So let's do some examples. Flip the page when you're ready. Here we go. So we've got some ordered pairs, and we are going to do all three things. So we're going to plot, we're going to put them in a table, and we're going to map. Here we go. Our first ordered pair is -4, -3. So I'm going to go left 4, because negatives are this way, right? -1, 2, 3, 4, and then down 1, 2, I put the lines under it, 3. Okay. So that's one of my points. Then I'm going to graph -2, +3. So this is -1, -2, +1, 2, 3. 0 tells me I'm not going in either direction, right? And then -4 tells me to go down 1, 2, 3, 4. And then 3, 1 over 1, 2, 3, up 1. Have you guys heard these referred to as quadrants too? Okay, so this would be quadrant 1. This is quadrant 2. So we actually label them not the way you would think. It's counterclockwise. So that's quadrant 2. This would be quadrant 3, and this would be quadrant 4. Okay, just so you know what the quadrants are labeled. I'm not going to ask any questions about that, but I just wanted to kind of discuss it while we were in a section where that kind of made sense to talk about. Okay, let's make a table. So here's my X, here's my Y. So my first ordered pair, I'm going to put it into my table. -4, -3. Again, the first piece is your X, the second piece is your Y, and they do have to be sitting right across from each other, because again, they have a relationship. -2, 3, 0, -4, 3, 1. Good? And then we need to make our bubbles. Domain and range. So you're going to make a bubble for your domain and a bubble for your range, and we're going to put everything in. Usually I like to organize my numbers from least to greatest, but in this case, like, it doesn't truly matter. Another way to organize them would be to have them just right across from each other, so it's easy to tell what matches up. And actually, I think that might be what I go with. Thank you. All right, so I'm going to go -4, -2, 0, and 3. So those are the values that are in my domain, because those are my X values. And then the range are my Y values. So I'm going to plug in my other numbers over here. -3, 3, -4, and 1. So this goes with this. This matches to this. This matches to this. This matches to this. So you show what value matches to the other. Okay, I'm going to have you try number 2 on your own. So, on your mark, get set, go. See if you can do number 2 without my help. I'm going to give you this so you can catch that up with us. So here's the first page. I'm ready with my answer. You guys finish up yours, and I'm going to put mine on the screen in just a second to make sure that we match. And there is actually another page today, because the other thing we kind of want to think about is graphs and how to read them and what they mean. So what they're kind of saying to us. Here we go. Does yours look like mine for the table? The bubbles for the domain and range to look at the relation of the points, and the graph. We're good? You can make graphs, or I also have graph paper in the back. Yep. So I keep graph paper for you guys, so you can always use that too. The graph paper is back there by like the pencils and the other extra stuff if you need it. Okay, a couple more things before we move to homework. Speaking of homework, take a look at the graph. The graph represents the amount of money Nora earns for different numbers of hours that she babysits. So we need to decide the independent and the dependent variable. So does the amount of money depend on the hours, or do the hours depend on the amount of money?
The money depends on the hours.
The money depends on the hours. So my independent variable, independent, is the time, or hours. My dependent variable is the money that I earn. Describe what's happening in the graph. So if you had to kind of make up a sentence to describe it, you would say, increase in money when there's an increase in hours. So there is an increase in money when there is an increase in hours. So you're just basically kind of like translating it out and saying what's happening. Number 4. Take a look at the graph, see what you think. We've got someone leaving for work. What do we think? Action. Left for work. And this is the distance that she is from her home. So does the distance depend on time, or does time depend on the distance? Depends the distance. So my independent, again, is my time.
Isn't that X usually the independent?
Usually, but not always. The dependent variable is going to be our distance from home. All right, so what happens with the distance from home over time? Am I heading home or am I heading away from home? Let's start with that. Heading home. So I'm getting closer, and then maybe I had to stop at a red light, and then I kept going. Would that kind of be a good story to describe what you see in the graph? Okay, so describe what happens in the graph. She was heading home. She stopped, and then she made it the rest of the way home. Skydiver jumped out of a plane, and the speed is in meters per second, and it was recorded. Identify the independent and dependent variables and sketch what a possible graph would look like. Okay, so we've got, let's go graph, and we've got our skydiver, and we've got speed over time. So what do you think I'm going to put on my x-axis? Time. And up here I'm going to put speed. Okay. I feel like you can make different arguments for how this might look, because here's kind of what I'm picturing, right? So we've got our friend jumping out of a plane. And when you start, are you really going quickly? Like not initially, right? Like you're going to pick up speed and pick up speed and pick up speed. So I would kind of say like it would look like this for picking up speed quickly. And then what happens at some point as you're like skydiving? You do what?
You play parachute.
You open your parachute. So at some point I'm going to continue increasing, but maybe not quite as quick. So do you see how I kind of used a different slope there? So my slope was a little bit bigger, and then I went a new slope that was a little bit different. So that's what my graph would look like there for speed over time. So my speed would increase, and then it would increase not quite as much once I pull my parachute. So again, you can kind of make up your own story as long as it makes sense for the situation, or as long as you could argue it to me if it was like a test or quiz question and say, hey, this is what I was thinking and your answer makes sense, I would be okay with it. So I feel like there are different ways to think through some of these problems. Assignment number 1. Sorry, I already wrote stuff for Tuesday up there. I'm like way ahead of the game. Alright, page 143 to 144 today. Numbers 1 through 8.
Is that actually it?
That's actually it.
Really? Okay.
Now some of them are going to have like all the parts, like the ones you just